So today I want to talk about OSC, which stands for Open Sound Control. In spirit, it's very much in the same category as MIDI. It's a communication protocol specification designed to allow you to send information, send data from device to device. In comparison to MIDI, though, it's a lot more flexible, it's newer, it lets you send a larger collection of data types. You're not limited to the sort of seven-bit pieces of information like MIDI, and you're not restricted to a rigid naming scheme like note on, note off, control change. MIDI has a lot that it can do, but I think OSC takes it a few steps further. SuperCollider is kind of founded on OSC. It's like as you know, it's two programs. It's the language and the server. And the language is the programming language with the interpreter and everything, and the server is the audio engine. And whenever we are working in the IDE and we play a synth or allocate a buffer, under the hood what's happening is the language is generating an OSC message, sending it to the server, which is then received and understood to result in some sort of action. So that's one way in which it's used, but it's the decoupling is very flexible in that you can send OSC messages from the language to somebody else's computer or a different piece of software on your machine. You can send OSC from like an iPad or an iPhone or an Android or something and receive it at your computer. So it's just this very fluid and expressive protocol for exchanging data. It's useful for laptop ensembles and stuff like that. So today I'm going to show you a few different ways that it can be used in SuperCollider. And we're going to start with TouchOSC, which is an app for iOS and Android. And I've got it running on my iPad over here. It's the app itself is like $5 last time I checked. So it's very, very cheap and very handy. It's a tool for building your own graphical interfaces that are multi-touch capable. If you don't have the right MIDI controller for something, you can design it yourself in TouchOSC. So this is kind of the main menu, I guess, for TouchOSC. And if we go to this middle part here where it says Layout Jog On, that's where you select the layout you want to use. And there's some that I've made over the years. And just haven't deleted yet, I guess, because a lot of these are just demonstrations. But you pick the one you want, and then in the upper right-hand corner, you hit the blue Done, and it takes you to that particular interface. And so this is just some, it doesn't do anything, but you can, you can push all the buttons, and it's very pretty. And then you can also make your own. You hit the little, I know this is like sideways, or there's a little dot here in the corner that'll take you back to the menu. There are other OSC apps like Lemur, which is more expensive, but it just gives you lots of options for designing. It's just a little bit more richly featured than TouchOSC. But I think TouchOSC is great for most applications. You can't build your own interfaces in the TouchOSC app. Instead, you build them in an app that runs on your computer called TouchOSC Editor, which is free to download. And the process is you basically build your interface and then you push it to your device. So we're going to make a really, really, really simple one. So we'll hide this for a second. Open TouchOSC Editor. And I think a lot of these features are kind of self-explanatory, and I have a tutorial, I think it's tutorial 11, which talks about TouchOSC. So it's not hard to find information on how to use this, but we're going to make just an iPad layout here. And let's see, I'll just put, I'm going to right click and make a push button. And maybe a fader. Nothing too fancy. And I'll save this as Simple 2021. And you want to save this in the Layouts folder, which is in the main TouchOSC folder, which goes in your applications folder. So we've saved this in the folder where your iPad or iPhone or whatever is gonna look for it. So we hit this sync button in the corner, and the computer app goes into a state where it's waiting for to be paired basically with a device, with like an iPad or something. So the way we do this is well, the first thing I think we want to do is go to the the OSC connections section here, and the most important thing you need to do here is to set the host IP address to be the computer that it's going to be talking to. And so you just need to know your IP address. And I'm using my local IP address. I'm on the Illinois network, and at least on Mac anyway, you can find this in network, and it's just right here. So I'm just going to copy this temporarily in here so I don't forget. We can quit out of this. And I've already done this ahead of time. I've got the right IP address. OSC Message Transmission needs two things. If you want to send a message from a device to a device, the sending device needs to know the address, the IP address of the receiving device, and it also needs to know the port on which that device is listening. And in, let's see, here, so the host IP address is my computer's IP address, and the local IP address of my iPad is, I can't change it, so it's just, it is what it is. But that's what it is in case I need it. And I'm having TouchOSC send OSC on port 57120 because in SuperCollider, that is the default port that the language is listening for OSC messages. You can change this, but you rarely need to. So and then if I want to send OSC from SuperCollider to my iPad, I would set the incoming port. In SuperCollider, I would say send on 9000 because that's the port that TouchOSC is listening to. So we have all the information we need to send OSC back and forth. So you just enter your the information here and just hit done a bunch of times, and then go back here. And I think TouchOSC editor is still syncing, so we're going to go to on the iPad layout, and then add at the very top. And sometimes the host device will automatically pop up here. Sometimes it doesn't. If it doesn't, you can hit edit in the upper right, and then the plus in the upper left. And now we just need to enter that IP address again. I think this was it. Okay, and then we just click on that host right here. And now Simple 2021 has been added to the list. So we'll click it and hit done. There we go. So we have a simple push button. It's a momentary button, so it's on if I hold my finger on it and off when I release. And then we have this slider, which seems to be upside down for some reason. Usually the color is below the thumb. It doesn't really matter. Okay, so we've got our device here. So now we're ready to actually listen for OSC in SuperCollider. And because we're going to be receiving it in the language, we don't even need to boot the server. We only need to boot the server if we want to make some sound. It is possible to send OSC directly to the server. I think the default port is 57110 instead of 57120. But I think it's theoretically just as easy. But the server expects certain messages, like make a new, with the specific OSC information, like make a new node, free a node, allocate a buffer. But when sending to the language, we can define any sort of, we can receive freely any kinds of messages or something like that. Oh, I forgot to show a couple of things in TouchOSC. So I'm just going to stop the sync here. So each of these two widgets we've made here, there's OSC information about them over here on the left. So specifically, I want you to take note of this tag here, this address tag. So the button when we send an OSC message, the message itself contains an address, which is sort of a URL style address, like slash this, slash that, slash whatever, and followed by any, one or more pieces of data, which can be numbers or, variety of things. So this button's address is /1/push1, and this fader's address is /1/fader1. We can turn off auto and make our own addresses if we want, but I'm just going to use these because they're already there. So we've already synced. We can actually, we'll keep this open just in case, but /1/push1, /1/fader1. We receive OSC and SuperCollider almost the exact same way we receive MIDI data. We make an OSC Def, which is a responder object. And normally, if we were doing MIDI def, we'd say, note on, CC, whatever. But there are no predetermined types, so we just say OSCDef.new. And the first thing we need is just a symbol, which we're going to use to refer to this OSC def, just like we do for synth-def, MIDI def, etc. So we'll say get touch OSC. And then a function to be evaluated when an OSC message comes in. So for now, we'll do this. And we also need, in addition to the key, the function, we need the path. This is that URL style address. And we do it in single quotes here, I think. Maybe there's other options, but I always do single quotes here. So, and then we can, there's some more options here, source ID, receive port, but we actually don't need any of that because we are using the default port. So we're already sending on 57.120, and that's already what the language is listening to. So all we need is just a name for this OSC def, a function to be executed when a message comes in, and the tag to match, basically. So we do this, and now if I push this button, we should see received in the post window, both when it's on and off. Yeah, okay. I don't know why it didn't come in immediately. There might be a little bit of latency or something, but no, it's working. It seems to be missing the first message somehow. But you know what I think it is? I think it's because I'm on this university network, which has a ton of traffic on it. If you have like a little router with a password and you set it up, I think it'll be much more reliable. But I'm using this, this big university network. So, but it's still working, right? It's coming in. So how do we get the actual data in? Like when we have a MIDI def, we want to get the node number, the velocity, the relevant information. And so we just declare an argument. It can be named whatever you want. And then we'll just see what it contains. So I press the button. Bring this up here. So we get the address. It's an array of two things, the address and the value. So on, off. Oh, see, I missed one of the offs. I think this is an Illinois network thing. So it's working. Slider doesn't do anything yet because there's nothing listening for that tag, but we can make one of those as well. And I think this is what, fader one. We should change these names because I should be more specific. So let's just get rid of them all, and then get push, and get fader. Yeah. I'm not sure why 0 is at the top. And did it think it got rotated somehow? Somehow the orientation is messed up. This is something I have not seen before, but that's okay. We'll just pretend we're upside down. So now just making sound is pretty trivial. We can, we'll say x equals synth default. X.set. Oh wait, we need to say if message at 1, because message is an array containing the address and the value. So we need to actually grab the thing we care about. If this equals 1, then create this synth. Otherwise, fade it out. And here we're going to say x.set amp message at 1. I'm being really messy here, you know, it's just, it might be the case that the synth doesn't exist and we're going to get node not found errors, but just doing this for a sort of pure demonstration here. Let's see if this works. QuickTime. You know, it's not right. So still some problems to work out, but it's working. Right, we're pulling data. We're generating OSC messages here in TouchOSC, and we're listening for them in SuperCollider. They come in, actions get executed, and we're in business. So there's lots of interesting stuff that you can do here. Make your own custom controllers. It's kind of it's been a popular topic for final projects in this class. Someone makes a TouchOSC interface. The only thing you want to keep in mind is that if you want to do something like that and send it to me, I need your TouchOSC file as well, because I need to put that into my layouts folder and push it to my device. So this is one common use of OSC, and it's not the only one. So let's we'll quit the server, and I think I'm actually done with my iPad for now. It is possible to send OSC from the language to the server, from the server to the language, and from the language to itself. It's all possible. Now, when we say synth default, like this. It's a nice high-level syntax that we can just see, and we sort of know what this means. Make a synth, use the default synth def, and then set its gate to 0. But what's happening under the hood is we're actually sending an OSC message to the server. And I think this is s_new is the address, which means make a new synth. And I always have to look at the reference file here called server command reference. I misspelled command. So here's another example here. So I think the next thing is the name of the synth def, a node ID. I'm just going to give it 4000 for no reason. These are usually assigned automatically. Or I think we can say s.next ID. Is that right? Next node ID. Yeah. So this is what's called internally, but we can use it ourselves if we feel like it. And I think this is the target and add action, but these get translated into lower level numbers. So 1 is the node ID of the default group, which is group ID 1, and 0 means add to head. So we can just do this, and the same thing happens. How about that? This is not as easy to decipher, certainly. And then if we want to free the synth, we can see that it has node ID 1005. I guess it's not add to head. It must be add after or something. So it's 1005. So send message n free for free a node 1005. There we go. Right. So this is you can do it this way too, but the higher level stuff kind of gets translated into OSC messages that go from language to server. They're two fully separate programs, and you can use some other program to send OSC to the server. You can use the language to send OSC to a server running on somebody else's computer or some other OSC program. Very flexible. Let's look real quick at how to send OSC to yourself. We'll call this, the address it'll be expecting is self. Okay, so we're ready and listening for any OSC messages to show up to this computer's IP address on port 57120 with the address tag /self. So how do we do that, right? So if I want to send it to myself, I need to make a net address. This is an object which represents a target, basically, an IP address and a port. And so it's going to be me. And it needs to be a string. You can't just do this by itself because that's syntactically invalid. It thinks it's a number with multiple decimal points. Can't do it. So it's a string and 57120. So this global variable me is me. Right? It's my computer. The IP address and port is listening to, so we can say me.sendMessage self, the number 56. So this is what gets printed as a convenience to say, yep, that's a net address, but then this is the result of the OSC Def receiving that message. Right? So I send an OSC message to my own computer on the port that my own computer is right now listening to, and this gets evaluated. And so this may not be immediately obvious, but you can now send OSC to me. You could have earlier too. So let's do a little proof of concept, world's crappiest laptop ensemble proof of concept. Okay, so what you should do is open up SuperCollider, make sure you're on Illinois net, and make a global variable. You don't have to call this me. You can call this Eli or teacher, whatever you want, and it should be a new instance of net address that is exactly like this. So just make a new instance of net address on your computer and evaluate it, and then send me something. Send me you just send a message to whatever you named that net address. The first one has to be this address tag, and then a number. It doesn't matter what it is because I'm just posting it. Just nothing nasty. Be well-behaved OSC messages only. I cannot guarantee this is going to work. Maybe it won't work, or there's like a chance my computer's going to say, "Do you want to accept incoming traffic from so and so?" Nope, here's one. That wasn't me. All right, so it's working. Why don't we make some sound? How about this? If message at 1 is number, that should work. All right, so now if you send me one of these, should make a sound. So now you can make sound come out of my computer. Look at that. We have our own little laptop ensemble. Very boring example, but you can imagine. This is one very very reasonable paradigm to go with, which is you have a bunch of people running SuperCollider, or really whatever. It's just one person is the server player, and that person is they've got their server booted, and they're in the language listening for incoming OSC messages, and filtering by tag, and like if it's this kind of message, do this. If it's that kind of message, do that, and maybe sanitize the data a little bit, just so nothing weird comes in. And you can do a lot of interesting stuff. You've got some effects and sound drones and things like that, and everyone can kind of influence them, and it's pretty cool. So again, just another nice little option for using OSC to do interesting stuff. Okay, so let's keep going here, and I guess I'm gonna free all of these. Party's over. There's a unit generator called send_reply. This is a UGen, like white noise, SINOSC, playbuff, and it's what it does is generates an OSC message and sends it from the server back to the language. This is useful for a variety of reasons. For example, when you open the server meters, there is a send reply that's part of a synth def, and a synth gets created whenever you open the meters, which is listening to the audio signal on these buses and tracking their average and peak amplitude using amplitude and peak. And then using send reply to, at a regular, it's like 20 times per second, it sends these values to the language where they are used to update this graphical user interface. I think these particular objects are an instance of level indicator. So you have 4 little level indicators here. And that's what these local host input levels are doing. These are little makeshift synth defs, and they've got a send reply in them. Send reply is just very, very useful if you have some sound process and you want that sound to influence something happening in the language, like a graphical user interface, or some animation happening on user view, or you just want to get it. You just want to know what's this thing's current value. So it's one of the very few ways to have data go the other direction. Usually we're in the language, we're saying make a sound, allocate this buffer, free this, start that, set that, and we're just talking from the language to the server. But there are cases where we want the server to give us information back, and that's what send reply does. Okay, so let's make a synth def here. What are we going to do here? Let's do okay, so we just have a little ocean wave generator. And we maybe want some, I don't know, just to keep it simple, a slider to move with the amplitude. So we want to use this unit generator to drive a slider. Let's go ahead and make the slider too. There's our slider. Okay, so we need to put a send reply into this synth def, and it just has to go somewhere after the actual signal we want to monitor has been created, and it should be running at the same rate as the signal we want to monitor. So send reply needs a trigger signal. This is like dust, or dust is a dumb choice. Impulse is usually the choice we do here, because it's going to give us a regular kind of frame rate, right? A regular series of triggers which say send, 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 right? So it depends on how fast we want to update this slider. You know, like usual frame rates are like 20, 30 frames per second, maybe 60 frames per second. So we're just going to say impulse KR 30. So 30 triggers per second. The OSC address, which is, I guess we haven't made the OSC responder yet, but we'll just call this noise amp. And then the actual value or values we want to send. And that's just going to be amp, this amplitude signal. There's another argument for reply ID. I don't remember what this does. I guess we could look it up. I guess it's an integer that will be passed. Okay, so it's to distinguish between multiple send replies or send trigs within the same. I think it's mostly useful for send trig. Send trig always sends with the address /tr, I think. Yeah, always sends with tr. And then if you have multiple send trigs, ID lets you distinguish which one is sending. But we don't need to worry about that. So we just need to say how often, give us a trigger signal to say when to send the message, the address to send the message with, and the actual values to attach to that address. Okay, so if we play this now, we're not going to see anything yet because we've only done half the work. We're sending the OSC. We need to make an OSC Def to receive it. There we go. And so now I just want to change the OSCDef function so that it talks to this slider. And I think we can just say, and it's not message at 1 here. Let's command period for just a moment. If we look at one of these messages, it contains 4 things. It's the OSC address, the node ID. Basically, I've hit command period, so it's gone. But if we were to go back here, the synth would have a node ID of 1004. I'm pretty sure that's what that is. -1, I think that's the reply ID. It defaults to -1 because we didn't specify otherwise. And then the item at index 3 is that's where the actual data begins. So we need to say message at 3. And if you remember from last week, tempo clock, system clock, MIDI defs, and OSC defs cannot interact directly with GUI objects because they're not in the main application context. So we're going to need to defer this. And I was tempted to let this happen accidentally on purpose, but it was just going to be a flood of error messages, and I think it was just maybe a little too much. So I'm going to nip this in the bud. And so we're going to have to defer the actual communication with GUI here. So synth-def, window, OSCDef, and here we go. OSC defs by default will not survive command period. They're non-permanent. But just like tempo clocks, you can make them permanent with permanent true. So like if we start this again here, wait a minute, hold on. What if we say OSC def? Maybe am I misremembering here? So there we go. Nothing. It's working. If we command period and run this again, yeah, doesn't work. But we can say now if we hit command period and then make the synth again, OSC def is still there. Probably don't need to see all that data anymore. It's I think when I was first learning about OSC, I thought it was going to be this crazy sort of thing, but it's really a very elegant and simple protocol. Right? Just every message just has a tag at the beginning and then some data, and you just need to know the IP address and the port, and you can just send to your heart's content. I have one last example, which this one I prepared ahead of time because I was worried I was going to mess it up. But I want to loop back around to GUI, and we're talking about user view and animations. So with the caveat that SuperCollider is not really optimized for heavy graphical stuff, it's still sort of fun to experiment with it. So what we're going to do in this example here is make a sound and make a user view and define some draw func, and then use send reply to take sound information, pass it back to the language, and map it onto the visuals so that they'll sort of follow the sound in some way. This is not a super interesting example. I think it takes time to make something which is like really visually and sonically compelling. But let's look at the SynthDef first. It is generating triggers using dust, so it's like impulse but stochastic, just random. By default, approximately 2 triggers per second. It's using that trigger signal. Every time there's a trigger, it selects a new frequency between 150 and 5,000. It also uses that trigger to, I'll write this out the way we usually do it, actually. Yeah. So it's going to receive a trigger for the gate, and so when it's a finite envelope like this, the trigger just restarts the envelope. Restart, restart, restart. And there's no done action too, because if it gets to the end, we want it to stay alive and wait for another trigger. Here's our sound source. We apply the envelope, and then we send the frequency value. That's what I've decided to send here. So the same trigger that's generating frequency values and controlling the envelope is the same one determining when values get sent to the language on the blip address, and we're passing these frequency values. So new frequency value, new frequency value. And let me first do this and comment this stuff out. So if we just make these two things, the SynthDef and the OSCDef, we should just see frequency data in the post window. And we can set the frequency. Yeah, the sounds sort of cut each other off because it's just one oscillator being retriggered, retriggered, retriggered. So it's not like a p-bind, which makes a sort of sequence of independent synths. So it's a little bit, you know, it's not as nice sounding, I guess. It's not as multi-layered. It's just monophonic. Okay, so we also make a window, which is always on top, and it has a user view with a dark background color. And we'll say every time it's refreshed, it's going to clear. So it's just going to clear itself each time. And we'll uncomment this part of the action function. So what the OSCDef does is it grabs the message, declares a local variable, which it sets equal to the third item in the array. So it's just, I just think it's a little nicer to have something called freak instead of message at 3, just so we know what data we're working with. And then it defers this func, because again, we can't talk to GUI straight from an OSCDef. So this is the stuff here. We say set the draw function of the user view to the following and refresh it. Refresh just actually causes the draw func to be evaluated. So every time an OSC message comes in, we update the draw func and draw it. And what it does is first it draws a, this part actually we can comment out for now because this, it just draws a transparent rectangle over the entire thing. So here's the meat and potatoes of it. We set the width of the pen. We set the stroke color to be a new color with 0.2 red, what is it? Yeah, 0.9 green, and then the blue amount of this color is mapped from the frequency. So if the frequency is low, there's not a lot of blue. Actually, let's do it the other way around. Let's make all blue with very low frequencies and no blue when the frequency is higher. And then we draw a circle. And the circle, if you recall, has 4 components to it. It's the center, so this is just going to be a random center somewhere. The center of the circle is somewhere on the canvas. And the frequency also determines the radius, which is going to be large with low frequencies. Low frequency, large radius. High frequency, small radius. And then we start at angle 0 and draw the arc 2 pi radians around, so it's a complete circle, and then we draw it. We construct it and then draw. So every time we get a trigger, we'll hear a sound and draw one of these circles on the canvas. And every time it gets refreshed, it's going to clear itself first. We can change the frequency, just update a synthesis parameter. Very sparse, right? Yeah. And then similar to that, did I show that bouncing ball example at the end of class? I did, yeah. So like the only sort of visual design trick I know is you draw a transparent layer at the beginning of every frame and you can do these trails. So we're not going to clear on refresh. And if we just stop here, it's going to just draw a new circle every time. Or we can uncomment this part, which sets the fill color of the pen to be, this is a dark gray, 0 is black, 1 is white, and so 0.2 is gray but close to black. And then this is the transparency value, with 0 is fully transparent, 1 is fully opaque. We draw a rectangle whose size is the bounds of the user view, so the entire thing, and then fill it with the fill color. And so that big circle at the very background is fading away a little bit more with each one. We're sort of putting another transparent layer above every circle. And yeah. So this is one way to do it. I'm thinking now, I'm just sort of, reevaluating what I did here. And I think it would be probably better, or at least more flexible, if we have a synth def that doesn't actually make any sound. So we'd get rid of this. And let's go ahead and see if we can mess. So no sound. The only job of this synth is to generate triggers and pass them back to the language. And then we can have a separate synth def, which could be any sort of sound. And this is a much better idea. Here's what we're going to do. So we'll just do this. Trig frequency, and we just need trig. And we're going to say 1. Just send the value 1. Doesn't matter. You could send anything, right? And then we'll make another synth def. Well, we'll just use the default synth def for convenience because it already exists. So what the OSC Def is going to do is, I'm not even sure we need the message, because it's like the 1 is just anything. When any message comes in from blip, it's going to do the action. I suppose we could also, no, we should be generating frequency values too. Let's do that. Equals T expand KR 50,000 trig. And we'll send freak. So that should still be good. It's not going to make any sound. And so freak equals message at 3, and we'll say synth. Oh, we'll do events here. Freak, not play. So if we just like set this to 200, say sustain 21. Okay, just a basic sound to work with here. So this is going to be the data received by the OSC Def, and then we're also going to draw one of these here. So this is called trig. I think everything is still fine here. So then we say send trig. Yeah, I mean this still sounds bad. It needs effects, needs reverb, needs a better sound. But just as a proof of concept here, and I think there's a latency parameter here. We need to say, yeah, maybe event is not the best model here, but I'll make another synth real quick. Just something really basic. Oh, I think I gotta get rid of these. Let's see, is that all good? Okay, just confirm. There we go, something slightly more interesting. And then here we're just gonna say synth sign freak. All right, okay, this should work. Another nice touch here would be to define arguments for the min and max of the trig synth so that we could dynamically adjust them. So anyway, that's the basic idea. The general workflow here is you make some sort of central synth, which is the driving process. You give it a send reply, and you give it a trigger, and every time there's a trigger, you pass back to the language as much information as you need. Use an OSC Def to receive that information, and then define the function to do whatever it needs to do. You can even make OSC Defs that receive OSC messages and in response send out OSC messages to other destinations and things like that. So it's a very, very flexible and fluid protocol, which I highly recommend using whenever you can. Okay, I think we have just one class left. this semester, right? You have break and then one more class. So I'll do a little bit of thinking and come up with something to discuss. But also, if you are working on your final projects and want to share or have questions, or let me know, and we'll put them on for the last class. Okay, so have a wonderful break, and I'll see you when we get back.